Occasionally, you're going to run into what's called a perfect square trinomial. A perfect square trinomial is created by squaring something. We'll take a look at that in a minute, but let's talk about what a perfect square is. A perfect square is a number that comes from something that was squared. In other words, you can factor it back into the square of a whole number. So here are some examples. 1 is a perfect square because when you square 1, you get 1. 4 is a perfect square because you get it from 2 squared. So 4 is 2 squared. 9 came from 3 squared. 16 came from 4 squared. So these numbers, 1, 4, 9, and 16, are perfect squares because they were the result of squaring a number. Now, I listed out a few here. I went up to 49, which is 7 times 7, but you could also do 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144, etc. You could go on forever. Likewise, there's an infinite number of perfect square trinomials. Now, to understand how to factor and recognize when you've got a perfect square trinomial, what we want to do is actually square some binomials out and see what it looks like when you have a binomial squared out. What does that trinomial end up looking like? So remember from previous math classes, when you have a binomial squared, like x plus 5 squared, that does not mean you can simply square the x and square the 5. X plus 5 quantity squared is really x plus 5 times x plus 5, and we've been doing a lot of FOILing lately. If you FOIL this out, you get x times x, or x squared. The outside is 5x, the inside is also 5x, and the last term, when I multiply them together, is 25. So these two middle terms end up being the same, 5x plus 5x, so we end up with 10x as a middle term. Again, you cannot simply distribute the square in the original problem up here. If you did, you would get the x squared and the 25, but you would totally miss out on the middle term. Let's do this again with the next example. X minus 6 squared would be x minus 6 times x minus 6. FOILing that out, we get x squared minus 6x plus 36. So that's x squared minus 12x plus 36. Once again, you get that x squared. Negative 6 squared is the 36, but then you've got that middle term, which comes from FOILing out the square. Last one, 3x plus 4 times 3x plus 4. FOILing, 9x squared plus outside 12x, inside is also 12x, and the last is 16. Collect like terms, 9x squared plus 24x plus 16. Again, the first and last terms were the squares of what you started with in your binomial, and the middle term is different. So when you square a binomial, you're always going to get 3 terms. You're going to get the square of the first term in the binomial and the last term in the binomial, but then you get this middle term. So what we want to think about for recognizing when we have a perfect square trinomial is we need a trinomial that has a square on both ends, and then the middle has to be in a very particular setting. And so let's go back. How does this 10x in this first example relate to where we started? Well, the 10x came from having 5x twice. 5x comes from multiplying the x and the 5 that we saw in the original binomial together. 10x comes from having 5 times x, or 5x, doubled, basically, times 2. So if we think about 5x times 2, that's how we get the 10x. Let's see if this pattern holds. In the next one, we've got a square here, a square here. If we think about multiplying the x and the 6 together, notice that's a negative 6. We get negative 6x, and then double it. So multiply by 2 means that we get negative 12x, and that's what we had. In this last one, we can do the same thing. 3x squared is 9x squared, 4 squared is 16, so these two terms are squares of what we started with. And in the middle, 3x times positive 4, 3 times 4 is 12x, and then if we double that, we get that 24x. So what you want to look for are squares on the edges of your trinomial, and double what the original factors would have been when multiplied in the middle. So that's what you're looking for if you happen to have a perfect square trinomial. Now that we've seen them created, let's see if we can recognize a perfect square trinomial when we have it multiplied out. So there are three things we're going to be looking for. Three things because there's three terms in a trinomial. The first thing we're looking for is that the first and last terms must be positive perfect squares. Positive numbers because when you square something, you're going to get a positive, whether you start with a negative or a positive. So in these three examples, the first term here is x squared, that's a square. The last term here is positive 16, so that's a perfect square as well because it's 4 times 4. So that one looks good so far. 9x squared, that's a perfect square, 3x times 3x. 64 is 8 squared and it's positive, so far these two are okay. The third example, x squared is x times x, that's a perfect square. Negative 25, there's an issue there. 25, if it were a positive, would be a perfect square. Because of the negative, this is not a perfect square. So therefore, right away we violated the first thing we're looking for in a perfect square trinomial. So this is not a perfect square trinomial, and we wouldn't be able to factor it as such. Now, maybe we can factor it some other way, but it's not a perfect square trinomial, so I'll leave it for now. The other thing we have to look for is the middle term. The middle term must be double the product of the square root of the first and last terms. Now, one way to do that is to actually look at factoring out what we started with, this first and this last term. So if I were to think about breaking that up into the square roots, this would be x, square root of x squared is x, and then 16, the square root of 16 is 4. Because my 8 is a positive, I'm going to use plus 4. And now let's check that. If I were to square that, take the 4 and the x that result, which are the square roots, 4 times x doubled. That should give you the middle term if this is a perfect square. Doubled, that would be 8x. There we go. There's my 8x. So this is a perfect square, and this should be my answer when I factor it out. It should be x plus 4 quantity squared. Always check to make sure you've done this right. X plus 4 quantity squared means I'm multiplying something by itself. That's x plus 4 times x plus 4. Foiling out, x squared plus outside is 4x, inside is 4x, and last term is 16. 4x plus 4x is 8x. That checks. All right, let's check the middle term on the next example. Again, let's start by undoing the squares, so square rooting. Undoing 9, square root of 9 is 3, x squared would be x, 64 would be 8. And now let's take a look. The sign of this middle term is positive, so we'd want to use a positive 8. Now, if this really is a perfect square trinomial, then 3 times 8, 3x I should say, times 8, should give us a number that when doubled takes us back to the middle term. And if you double 24, so multiply it by 2, you do get 48x. So I just need to put that square on, which I didn't do yet, and that should be our answer. Let's check it. 3x plus 8 squared is really 3x plus 8 times itself. 3x times 3x is 9x squared plus 24x plus 24x plus last terms are 64. So I'm just foiling this. 9x squared plus 48x plus 64. That's where we started. So if you happen to have a perfect square trinomial, and that takes recognizing, then you can actually very quickly go to your answer and write it as a binomial square. One last note on this process. This is a special case for factoring trinomials. As a special case, it's just a quick way of getting there. You can always factor a perfect square trinomial the traditional way using the methods we've already gone over this term. So the AC method, the trial and error method, all of those will work just fine. So if you don't recognize it's a perfect square trinomial, if you instead just start factoring like normal, you will still get the same answer.